parallelograms, which really we're starting with a mark doesn't work. Oh, see, I had this thrown out. Alright, so rectangle. I would assume, guys, everyone with a rectangle is okay with finding area of this. This is the area that you would have been doing since whenever the heck they started area. Okay? Where you're doing length times width, but the difference is now, just to tie it into other formulas, you'll be doing base times height. Okay? Now, the reason it's going to be written that way is because this will lead you into how to do a parallelogram. It'll also lead you into how to do a triangle, because they're all based on that formula right there. And then triangle is going to lead you into doing like trapezoids and so on. So this shapes like this with a rectangle you've been doing for quite a while. Okay. All right. Now parallelograms. Remember, this is technically a parallelogram, correct? Okay. And even if I took this shape and I drew it as a parallelogram where it's tilted, you understand, you're not really altering the shape, you're just kind of making it skewed so that the actual space, the region that's inside here isn't really changing. I can still fit the same number of cubic or square units in there, which means I'm still going to be able to use the same formula to find it. The difference here is when you see the height on parallelograms, they'll have to give you some kind of measurement inside of it for the height, and the base will just be whatever side this is connected to. Okay, but your area formulas for parallelograms are still just going to be base times height. The height can also be drawn out here, and usually if it's drawn on the outside of it, they'll extend this out. Just this dashed line isn't part of the shape, just remember that. So if they put a number here, ignore it. You're only concerned with the actual side lengths for the B part, the base, and then the height is just the distance between them. Your base and height, these things are always making, make a right angle. So if you're unsure about which numbers to pick, you look for the right angle. Whatever two numbers are connecting, like to form that right angle, those are the numbers you use them for base and height. I can do them both because they're both pretty quick. Parallelograms, for the most part, are fast to do. For this one here, there's 3 measurements up there. We only need 2 of them.
4 and 5.
The 4 and 5, right? Because the 4 and 5 are the only ones making the right angle. So the 4.5 is just this side, but I don't really care about it in this case. So the area here would just be 4 times 5, which is, what's 4 times 5?
20.
20 square inches. And I said, look, okay, here's your parallelogram. This measurement down here is 10. That's the height, that's what we're trying to find, but I tell you, like, the area is 50, whatever the heck the units are, okay? So the idea with this is, and this will go for any kind of problem we're doing where it's like I tell you the area and say find one part that's missing, is I know like the area formula, is that correct?
Would that be 50 squared?
No, 50, whatever the units are. So the idea is, look, if I know what the formula is and I know what the area is, you just plug in the numbers where you know them. So I know the area is 50, so I'm going to put a 50 in place of that. The base is this one, that's my base, because this is the side that's connected to the whole right angle. So it's going to say 10, and the h is what I'm trying to find. You should be able to solve that equation. Should be 5.
Wait,
like I said, 9 makes that, like the thing that's measured out 9, the whole dashed line up there, it does make a right angle, correct? Right here? Okay, so this line right here is connected to this side, so that means I can find the area using these two. Like I can treat this as a base and that as a height, it's just turned sideways. So that if you took it and like moved it that way, now you can look at it as base and height. Okay? so that I can go, okay, if I know that this and this connect, like these two sides connect to make a right angle, I can do 13 times 9 to get the area. So what's 13 times 9? 117. Now, even if I take that shape and I like shift it back to there, does the area of the actual shape change? Like if I start rotating it around and I don't change the shape at all, the area is the same, correct?
Yeah.
Okay? So that means that this number right now will never change regardless of how I look at it. So if I look at it from this perspective, this line and this one are making a right angle, correct? So like this side, this line now can be my height, which is what I want to try and find, and that can be my base. And if I multiply these together, all right, if I multiply like 9.4 times the height and treat this as the height, I can still find the area, but I know this number from here, so I can take that, pop it in there, and solve out for it.
When this problem was given to you, like...
So what's 117 divided by 9.4? 12.4? Hey, you wish. Never. Alright, so again, triangle guys doing the area, this shouldn't be a new thing. You did it at the very beginning of this year. You've done it in the past. You should have done it in the past. And again, the idea is, I said, all the formulas you're dealing with today, or the majority of them, are going to be stemming from this shape, which we already did this, moved into a parallelogram. And then for a triangle, the whole idea is if I take a rectangle, cut it like that, and create a triangle, I've essentially made a triangle out of what is 1/2 of a rectangle. Okay, and that's where the whole idea of the formula for the area of a triangle being 1/2 base times height, because a triangle is in reality, like if I base it on this, it's 1/2 of a rectangle. So the BH part's your rectangle, that's half of it. Again, just like in the last couple problems, I said these two, right, the B and the H, they're still going to always make a right angle. So regardless of what direction these triangles are drawn, if they're like this, you need to see a right angle there for that to be the height, that to be the base. All right, doesn't matter which direction you draw it. If you draw it this way, that's going to be the height, that's going to be the base, because they're making the right angle. The one in the middle here, again, these two sides are the ones that are making the right angle. So these are your base and height. It doesn't matter which one you call which, because you're multiplying. So like in this one, when I set it up, I would just be doing 1/2 of 6 times 4.5, which is 3 times 4.5, which is how much? Someone help me out there.
It's like
13.5.
Divided by 2.
It's already divided by 2. Okay? So with the right triangle, just look for the two sides that are not the hypotenuse. Those are always going to be the base and height. This one over here, again, like I said, if you're doing a problem like this, when they give you the dash line and they put a number next to it, it doesn't matter. You don't need this. All you're going to be concerned with is going to be the length of the actual side, because this would be your base, and then the height from the tip top down to where that base would be. So this is there to just kind of throw you off. So if you were doing this one, you'd be doing 1/2 of 2 times 3, which is just 3. Okay? The biggest difference between the formulas and the stuff we work with triangles and trapezoids is trapezoids have 2 bases. So it means anywhere we had a base for a triangle, now we've got to put 2 bases in there. So you essentially are still doing 1/2 base times height. It's just to create that one base, you have to combine base 1 and base 2 by adding them. Okay? So it's still the same formula as if it was a triangle, right? Because again, they're all going to be very similar. The difference is to create that base in terms of 1/2 base times height, you have to add together the 2 parallel sides. So like this one here, I guess they really should have had arrows here for this one showing you that 38 was the entire side. This would be the more straightforward one because they tell you all of the measurements you need. Because you have the right angle here, so I know that's a height. So it's 1/2 that. This is the complete base down here. That's the complete one up top. So this one would be the most straightforward because all the numbers are there. There's nothing for you to find. Okay? So 1/2 of 16 times. It's 38 plus 21.
8 times 59.
Yeah, 8 times 59, which is
Which is a big number.
472.
472. And I got units, so square units. Alright. The other one still isn't that bad. It's just now I'm missing the height and I'm missing the entire base. At least right away I am. But with the way this thing is set up, they're telling me like from here to here is 6. Which, if I took this piece and slid it over here, would I change the length of it? If I just took it and slid it, does it change the length?
No.
No. So that means that from here to here is still 6. So from down here all the way up to the top would be how long?
90.
9. Right? Because 6 plus 3 would be 9. So these are the two sides. These are the two sides that are parallel. So since they're parallel, those are my bases. So my area would be like 1/2. I'll put the height there. Okay. Now look, the height isn't there, right? Correct?
Correct.
Right.
So at the top portion, if I kind of redrew it out, they give you a 3 there, they give you a 5, and that's my height. Right? Because this is really all I'm looking at. This portion right now doesn't matter. If you're missing something, guys, I told you in the past, if you're missing something, you're going to do something with the right triangle to find it. With the exception of like the slide.
Oh, no, it's like...
Okay? So here's the thing. I've got 2 side lengths, correct? Do I have 2 side lengths of that
Yeah,
triangle?
Can you do A2 plus B2 plus C2? Yes.
You can do that.
Oh, disgusting.
All right?
That's what
Or I also told you, like, this is one of those triangles that's going to come up a lot. If the longest side is 5 and one of the other sides is 3, this side is 4. 3, 4, 5 is a very, very common side lengths for right triangles.
Wait.
What is 6 plus 9?
So I've got that now. Okay?
What's 25 minus 9?
16. Both diagonals of any quadrilateral. These only come up for a rhombus and a kite, but this actually works for all of them. Any kind of 4-sided shape, if you have both those diagonals. Okay? You do the 2 diagonals multiplied together and then take half of it. And you have to have measurements from one side to the other. Now the reason they bring this up solely for like a rhombus and a kite is because, as like a side note, yeah, this goes back to whenever we did these. In those shapes up there, which guys also this includes a square. Those 2 are perpendicular, right? Meaning they make right angles. The entire diagonal. So when you do it, you multiply it. But the only way I can get this entire thing is if I add those 2 numbers together. So to get, you're only going to do an adding if it's, you need to get the entire length. Because like for here, D1 is like, let's say this is diagonal 1. That would be 8 plus 8, which is 16. And the other one would be 10 because it's 8 plus 2. So when you do your work, it's just going to be 1/2 of 16 times 10, which is 8. With these, you're only going to see these as rhombus. This goes back to when we did all the properties for rhombus. In a rhombus, guys, the reason they're only going to give you 2 numbers here instead of like all of them like the last ones were for the kite is because this measurement and that measurement are identical. So like if this is 30, that's also 30. So I know like one of that diagonals is 60 and the other one would be 20 and 20, which is 40. So the area would just be 1/2 of 6 plus 40, which is, was it 1,200?
50. 240. No, 2,400.
What? Well, half of that, 12.
Oh. No? How? Oh, I added. 60 times 40.
Okay, this one here, this is another very common one with the rhombus. They're going to give you this because you know that in order to find this, I need both the diagonals. This is one of them. Okay, so I got one of the numbers there being 6. All right, the other one, if I drew it in there, using what was over on the last one, as soon as you draw this diagonal in there, it's going to take this one that you already know and cut it into 2 equal parts. And also the diagonals for a rhombus make a right angle. Meaning that if you look solely at this triangle, because again I said if something's missing you're going to do something with the right triangle. Usually it's Pythagorean theorem stuff right now. I can find that side right there, which again this is a 3, 4, 5 right triangle, or if you want to do Pythagorean theorem, you can do it like that and still get the same number. Okay, so you can get this side here by creating it. You would have to draw on the other diagonal. This diagonal splits the one you already know. And then once it's split, you would do Pythagorean theorem to get that side. And again, since it's a rhombus, if that's 4, that side's also 4. So that means this entire diagonal would be 8. So that would be 24.